I'll forget like the next 3 days. Okay. We're on this next section, 3.4, which is going to continue some of the things that we did talk about in the last section. Like we're still going to be using synthetic division. We're still going to be trying to find our roots like we did in the last section with dividing. But you're going to start dealing with maybe more complicated polynomials, and they may not give you any roots to start with. And we kind of talked about how to approach that. So we're going to get into that a little bit more and looking at how to actually find all the answers, whether they're whole numbers, decimals, maybe they deal with square roots, maybe they have imaginary numbers. So how do we find all of the answers to these polynomials? We've talked about the rational zero theorem, or not the rational zero theorem. We talked about using like the synthetic division, where if you know a root, or if you're maybe testing to see if a root works, that you could put that in to figure out, that was that remainder theorem. You could figure out if it worked or not. So we're still going to be using a little bit of that. But we have something else out there called the rational zero theorem, which allows us to look at a polynomial and figure out what would maybe be potential like whole number answers. So if they give me nothing to start on, and I want to figure out where would be a good spot to maybe start looking, so I'm not just having to guess and check all these numbers all the time, we can use this theorem to help us figure out kind of a smaller, more specific list of numbers to focus on. And then that also plays into like when we go to our tables, we know maybe what numbers to be looking at to help us find our first zero so we can get going with the process. To do that, we're going to do like listing out all these numbers using two pieces from our equation. One of them is sometimes known as like the P, and one of them is known as the Q. And so we're going to do like P's over Q's, which again, you might have done this last year in Algebra 2. We talked about doing P's over Q's. And so up here it says you're going to find the factors of your constant term. That's known as your P term. Then you're going to find factors of your leading coefficient, and that's going to be your Q. So the constant term would be like the number at the very end of your equation with no letter attached to it. And then the leading coefficient would be the number in front of the term with the highest degree. And then you're going to divide all of these. You're going to take P over Q. Okay, and this is just what they use to write out how you would set up this problem in order to help you find the possible answers out there. So let's do an example here together. Looking at this equation, 4x to the fifth plus 12x to the fourth minus x minus 3. What is my constant? What's the number with no letter attached? The negative 3. Now, I don't really need to worry so much about signs right now, so I'm just going to focus on the 3. And what would be my leading coefficient? 4. So 3 is my P, 4 is my Q. And when we set this up, I'm thinking about factors for both of these numbers right now. So what are numbers that you could multiply and get 3? And there's not very many. 3 and 1. How about for 4? And 1 and 4. So I'm going to write 1, 2, 4. So those are your factors. Think about almost like you're factor treeing it. You're trying to get down to all the numbers that you could maybe make possible combinations with. Okay, now what we're going to do is set this up. So we're going to put P's over Q's. So these top numbers, the 1 and the 3, those are going to individually be divided by all the Q numbers that you have. So you're going to, I always start it with the 1, and I take 1 divided by all the numbers down here. So 1 divided by 1 is just a 1. 1 divided by 2 would be a half. And then 1 divided by 4 would be a fourth. And then we're going to keep going with the other number. Because I did 1 divided by all of those. Now we're going to do 3 divided by these numbers. So what would be 3 divided by 1? 3. And then 3 divided by 2 would just be 3 over 2. I'm just going to leave it as a fraction. And then 3 over 4. And then out front, I'm going to put a plus or minus sign. Because it could be the positive or the negative root here. Because your signs up above in your equation could change, and it could cause it to be a positive or a negative root. Once you have this list here, this gives you kind of just an idea of these are the numbers that would work for them to be possibly showing up on your table. Then if we needed to start solving it, we would go to our table next, okay? But right now we're just practicing P's and Q's. So I would like you guys to do the next one by yourself. Write out your list for P's and Q's. All right, what's your P for this one? Okay, I'm just going to put 2 down. Q? Okay, what are factors of 2? 1 and 2. Factors of 15?
1, 3, 5, 15.
Good. Okay, now we're going to start doing P's over Q's. And earlier I took like the 1 divided by everything and then the 2. Some will do it the opposite. They'll take all the P's divided by the first Q, and they'll take all the P's divided by the second Q. It really doesn't matter how you do it because you're just trying to write out a list of numbers here. So if I did all the division, what did you guys write out for possible answers here? 1. Hold on. 1/3 what?
1 over 5.
Did you do?
Oh, wait, no, I don't know. I'm just going.
Oh, 1 over 5. Okay. And then?
1 over 15.
Okay.
2.
Okay.
2 over 3. 2 over 5. And 2 over 15.
Good. I'm just going to show you what it would look like if someone went about it the other direction. So if they took the 1 and the 2 all divided by 1, it would be plus or minus 1 and then the 2. And then they would write 1/3, 2/3, 1/5, 2/5, and then 1/15, 2/15. You can see though that they still match what I had up above. They're just in a different order. And it just depends on if you want to go through all your P's and divide by Q's individually first, or if you want to start with 1 P divided by all the Q's, and then do the next P divided by all the Q's. But you get the same list of numbers here. So I would take either answer if you were writing those out. All right, are we good on doing P's over Q's?
Yes.
Okay, so now what we're going to do is these next couple of examples, we're actually going to continue off of these. So we're not going to redo this process, but this is the first step that you would start with, is you would figure out what is my P's over Q's so I get kind of an idea of what I'm working with here for possible roots that would show up on my table. So on the next example, it says to use synthetic division and find the rational zeros, and it says to continue from the above problem. We're talking about this one right now. This is the above problem that they're referring to. So down here, they wrote out that list, and this is the same list that we had written out earlier, the 1, the 1/2, the 1/4, the 3, the 3/2, and the 3/4. Okay, those are all my possible roots. I'll just write that equation down here again, because this is where, if you're going like pages back and forth, it might be best to have it just written down so we know what we're working with. Okay, so what I want to do is try to find the other roots, and this is when I go to my table here. So if you have a calculator, I want you guys to hit your table button, and you're going to type in that equation, 4x to the 5th plus 12x to the 4th minus x minus 3. Then I'm going to go to the table, and to start, I would just begin with those whole numbers. We have a 1 and a 3 in our list that are just not fractions, but it could be positive 1 or negative 1, could be positive 3 or negative 3. So I would maybe start on those numbers. If those don't show up ever, then we might have to look at fractions. but usually the ones that we're going to provide you guys with to practice this, you're probably going to be able to find a whole number. So go to your table, and I want you guys to tell me, does like positive 1 or 3 or does negative 1 or 3 work? One of them should work. What? I thought someone said something. What are you guys finding on your table? Negative 3 works because you get a 0 in the y column. That's how you know that it would go in perfectly. So negative 3 in our table shows us that it should not give us a remainder. So I'm going to use negative 3. So I'm going to put that down here in my box. Negative 3 is a 0 that we found from our table. And then I need to list out all my coefficients. Make sure that you account for anything that's skipped. Okay, so what are we going to start with here?
4.
And then?
12.
Then?
0.
Then?
0.
Keep going.
Negative 1. Negative 3.
Okay, remember we have those zeros in the middle because it skips over x to the third and x squared. So we have to hold a place for that. All right. We're going to drop the first 4. Nothing about this process has changed. Should come out like that, a lot of zeros. It's kind of nice. So now if I'm going to write it out, I would start 4x to the 4th power. There's no need for me to write 0x to the third, 0x squared, 0x. Like that doesn't do anything for me. So I'm just going to write minus 1 equals 0. This is known as a depressed polynomial, okay, because it goes down 1. It's not because it's sad. It's because it goes down 1 from the original exponent. So like it started with a 5 up here. So your new one now is called depressed because it went down 1 to an x to the 4th. Okay, but this is maybe now easier for us to solve to find the other possible roots. Okay, so it says to use synthetic division to reduce. Oh, I already did that. So like this answer here, I should have written down a number 2. I didn't realize that they had me separate that out. This is my depressed polynomial. Okay, and then they're asking you on step number 3, use your depressed polynomial to finish finding the real roots. So that means let's solve for x here. What would you guys do first? Add 1, so it says 4x to the 4th equals 1. Then what? Then what? How do you get rid of the 4th root? Like that? Is that what you mean? But like with a 4, right? That'd be called like the 4th root. You're trying to find the 4th root of it. You're probably not going to get a nice number here. I mean, the top is fine. But for right now, I'm just going to leave it here. And so I'm just going to write at the bottom my roots. Or you could say zeros, solutions. You could say these are my x-intercepts. These are my answers. However you want to state that. Are going to be that one that we started with. What was the very first one that we found on our table? Negative 3. And then this one. I'm just going to write it as the 4th root of 1/4. These would be my roots. Now, I just want you to think about this for a second. When you began, so going way back up here to the top, what degree was the original polynomial? The original problem had a 5, okay? That means that there's up to 5 answers out there that we could have possibly found. Now, down below, we have 1 is the negative 3. And then that 1/4, with it being the 4th root, it really shows up 4 times. So that would have multiplicity. But that is showing all 5 roots there. Now, not all of them will be able to be solved like this. We might have to talk about different ways to solve them. Okay, so let's do another example. Okay, this next one wants us to finish that second problem that we did the P's and Q's for. Okay, so you already did your P's and Q's. We did that back on the first page. Okay, that was the 1, 2, 1/3, 2/3, 1/5, 2/5, that big list. Okay, so we found our P's and Q's already. Because again, it says finish the above problem. This is from the first page. So can you guys go to your table, type that equation in, and I need you to find a root for me.
-1.
-1?
Oh, okay.
If there's another one, like if +1 were to work, it doesn't really matter which one you use to start. You can decide. Okay, but if it doesn't work, then no, you can't use it. Unless it has a 0, you can't use that number, okay? Because it's not going to be helpful to us. All right, what are my coefficients for this one?
15, 14, -3, -2.
Too many sweats.
All right, let's remember we know we should get a 0 for our remainder because that's the whole reason why we chose this number. Okay, how would I write my depressed polynomial?
15x squared -1.
Can I just write minus x
Yeah, -2.
equals 0? I think we had this problem before. Like, I feel like we've seen this factoring problem in the past.
Looks like we
Because what's 15 times a -2?
30.
So multiply to -30, and my middle term is a -1. Are there numbers that multiply to -30 add to -1?
6 and 5.
6 and 5. Which one's negative? 6. So now we're going to factor this, but we split that middle term. So we're going to write 15x squared. I'm going to put the 5 first, just because I know that'll go in with the 15 nicely. And then minus 6x minus 2. And this is now, we're setting it equal to 0, because we are trying to find the roots now. Before, we've maybe just factored and we've left it there, but I do want to find my zeros at this point. And I'm just going to circle that -1 up here so I would just remind myself, like, that is one of my answers. I need to find the other ones now, though. So if we group, what can we take out of our first grouping? And that would leave me with, from the second set? Good, -2. Okay, so we've got 5x minus 2. We've got 3x plus 1. If I set those both equal to 0, what are we getting for answers? 2/5 and -1/3. So back up here at the top, what are all my roots?
Sound like your.
Kind of. There's my roots. And I'm not going to be so worried about order. Like if you guys have them out of order, I usually put them in like smallest to biggest, but I'm just going to care that they're all there. I want you guys to be able to find them, and then however you write them is good. And if you think about it, back on that list, like if you guys go back to your first page, that second example we did the P's and Q's on, all of them are in that list. Like the -1 is in there, the 2/5 is in there, and the -1/3 is in there. It's just those other ones didn't show up on your table because your table was set to be only showing you the whole numbers. We could go in and we could change the settings of our table and actually see those fractions. But I don't know if that's worth the time trying to do all of that, other than just solving it by factoring. All right. I think we've got time for one more today, kind of in this chunk here. But this one is wanting us to do the whole thing from start to finish. We don't have like our P's and Q's list to begin with. So we need to start there first. What's my P?
-2.
And what's my Q?
1.
What are factors of 2?
1 and 2.
And factors of 1? 1. My list is going to be really short here. What's my P's over Q's?
1.
1 and 2. No fractions this time. Okay. So go to your table. Type that equation in, and I want you to tell me one that works. 2 works. And what are my coefficients?
1.
1, 1,
-5.
Good. Okay, so I'm doing my synthetic division. What's my depressed polynomial?
X squared plus 3a. That's 1.
Good. And I'm thinking about setting this equal to 0. So I would try to factor if I can. Can I factor this one though? No, you can't multiply to 1 and add to 3. It's just not possible to do that. So if I can't factor it, what do I need to use? What? The quadratic formula. Good job. You got it. So we have to use quadratic formula here. There's no really way around that. I mean, you could try completing the square, but I would not advise you to do that.
Yeah, go ahead.
Okay, what number are we putting in for B?
Um,
Good. 3. So -3 plus or minus 3 squared. What's my A?
1.
1. And the C?
1,
1. All over 2
1.
times 1. Good. Okay, so we've got -3 here, plus or minus. What does underneath the square root become?
Oh, wait, I remember. 13.
Oh, I got a lot of numbers being thrown out here. 5, because 3 squared is 9. And then 4 times 1 times 1 is 4. 9 minus 4 would just be a 5. All over a 2. I would just leave it here, guys. There's no reducing that can be done. Like the whole numbers, you can't do anything. So let's write out our roots. What are all of them? 2. And this whole mess. -3. Yep. We are done for today.
Boom.
Those are your roots.